All right, everybody, let's go ahead and get today's program started. Good afternoon, folks. Welcome to the Lunchtime Discovery Series. It is good, as always, to be with you again for another edition of our program. My name is Chris Smith. I am your host for the Lunchtime Discovery Series. I work over here at the North Carolina Museum of Natural Sciences, from where we are delivering you this fantastic program. Our broadcast is coming at you live. Well, I guess technically it's coming at you live from lots of different places today because our guest is not here in the museum with me, but we're going to get to that in just a moment. The program is also organized and coordinated by the folks over in the Office of Environmental Education within the Department of Environmental Quality within the state of North Carolina, our sister organization, working together to try to bring you great programming every single Wednesday. And we have a good time at this show, right? I enjoy it. We all gather here around the glow of our YouTube screens and have the opportunity to meet interesting people who are doing some fascinating science and conservation and education and art and more, all here in the state of North Carolina and beyond sometimes. We get a chance to learn about what's happening out there in the world and how it applies to us and how we can use it in our daily lives. So I hope that you're enjoying this program. Well, you're here. I think you're having a great time already, but I'm glad that you're here and I'm ready to get into today's program. Now, the topic of the day is, in a way, a topic that I enjoy learning a lot about. Like when I was in grad school, I spent a lot of time thinking about, reading, and researching stuff around climate change, impacts of climate change. And one of those things that we talk about a lot here in North Carolina is sea level rise, because we have coastline, which was a little bit new to me coming from Tennessee to North Carolina. We don't think about sea level rise so much in Tennessee, but we talk about it a lot here in North Carolina. And so I've had the opportunity to learn a little bit about it, but it's always good to hear from people who are thinking about it a lot, who have devoted time and expertise and resources to helping us all learn about it more. And today we have such a person, somebody who's going to give us some great scientific research and insights and expertise into what's facing North Carolinians. Probably not just on the coast, I'm going to imagine, but something that impacts all of us. So everybody, let me introduce to you Dr. Katherine Anarde. Dr. Anarde is an assistant professor at North Carolina State University in the Department of Civil, Construction, and Environmental Engineering, and works in coastal engineering specifically. Dr. Anarde, welcome to the show.
Thank you so much. I'm very excited to be here. Jazzed to talk about sea level rise and its impact to coastal Carolina communities.
I'm excited. Lately the big climate meetings, I guess this year, where were they? In Dubai, have been going on. And so there have been headlines around what like nation states are doing and what they're thinking about climate change. But it's interesting to really get down into like the neighborhood level as well.
Yeah, that's exactly what we're going to be doing today. So we'll start with a national look on flooding, and then zoom to North Carolina, and then zoom further to specific communities that we're working in, and think about the problem from a scientific viewpoint, but then also talk about how communities are trying to mitigate flooding and looking into the future about how it might change and how the solutions might need to change.
Exciting stuff. We'll get to the learning, and I'll turn it over to you.
Okay. I am going to share my screen. This is always the most nerve-wracking part.
And while you're doing that, I'll remind all of our viewers that as we go throughout the program, you can help me out, your host, by dropping your questions for our guest speaker in the chat as you have them throughout the program. After the presentation, we'll be turning to all of you for your thoughts and questions.
Okay, Chris, can you see my slides? Are we good?
Looks good.
Okay. So thanks again for having me here today. The talk, or the title of my talk, is "It's Flooding More Than We Know." And I'm presenting this information today on behalf of a lot of people. So this project is really based out of two institutions, two academic institutions. That's NC State University and then UNC Chapel Hill. So my co-lead on the project is Dr. Miyuki Hino. She's an environmental social scientist at UNC Chapel Hill. But we have a small army of academic researchers and technical staff, electrical engineers, social scientists from different institutions across the state, spanning UNC, UNCG, NC State, and UNCW. And then we also have community partners within the town of Beaufort, the city of New Bern, the town of Carolina Beach, and the Down East Carteret County region at Core Sounds Waterfowl Museum and Heritage Center, and then the Museum of Life and Science, Max Colley. So I highlight my collaborators and co-authors here, and then I will zoom into each of them throughout the talk. And then our funders are at the bottom, and it's a large list of funders, and I'll try to zoom into the specific projects and throughout the talk. So like Chris mentioned, flooding from sea level rise is a global problem. And nationally, we've had cities make headlines on floods occurring outside of extreme events in some of the more populous metropolitan areas. So New York City, Miami, Florida, here, Hollywood, Florida, San Francisco, California, shown on the upper right, Norfolk, and Honolulu. But we also see flooding in North Carolina outside of extreme events. Pretty recently, this is an aerial of Carolina Beach, looking from the bay to the ocean, and you can see that the whole roadway, so this is Canal Drive, was flooded back in November 2021. And it looks like this a lot during the year, and I'll provide you with data and models to demonstrate that this is the case. We also have flooding in the more inner sound areas or inner banks. So this is a video from Marshallburg in Down East Carteret County back in September of this year. So showing complete inundation of the marsh and some key roadways. So we've seen flooding beyond just the past couple of years in coastal North Carolina due to sea level rise. So this is a photo taken by Christine Voss, back in 2015 in Beaufort, North Carolina, showing flooding of a sidewalk. And this is really the beginning of the North Carolina King Tides program, or King Tides project. So there was a large push to put gauges across the state, and this is part of a more national effort to try to track flooding from king tides. So this is a gauge over at UNC IMS, and Chris Voss really led the effort here in North Carolina. And a product of this program was this annual King Tides calendar. So this is the 2023 King Tides calendar, where the king tides, or the largest high tides of the year, are highlighted in orange. And we'll see in December, there are no predicted or expected king tide events, but we do have a super full moon and are coming up, or no, we don't. We have a full moon coming up, but the king tide events typically coincide with the super full or super new moon. So when the moon is in perigee, and when it's full or new. So what do I mean by that? So this coinciding of a new or full moon with perigee, so perigee being when the moon is closest to the Earth in its monthly orbit, when that occurs, coinciding with the alignment of the Earth, the moon, and the sun, we have a new moon if the moon is between Earth and the sun, and we have a full moon when the moon is on the opposite side of the sun. So the moon is what exerts the largest gravitational pull on the Earth's oceans and creates these bulges that we know as the tides. So when we have this coincidence of the Earth, moon, sun in alignment, we get the largest tidal ranges of the year. So these are the king tides, and they occur 6 to 8 times per year. And we're able to predict them pretty well. But in North Carolina, it's not just the tides that matter for marine water levels. There are some other factors that contribute to high water levels in the state outside of extreme events. So we're going to call this the tide wind continuum. We have these massive estuaries in North Carolina, and winds can act over those estuaries and really push water up into shorelines on the backside of our barrier islands. So what I'm showing here is some data that was collected by Chris Voss that shows the water level, the observed water level in black, and the predicted tides on a bayside location on the top, and then on the ocean side location on the bottom. So we'd expect a larger tidal range along the ocean and a smaller tidal range within our estuaries and bays. But what we observe in coastal North Carolina is that the water levels and the tidal response within our estuaries can really be impacted by the direction of the wind. So winds really matter in our state. And going back to this flood event in September, and how we tracked flooding from tidal events back in 2015, I'm now showing on the right a prediction from NOAA of the tides during this time period. So this is a couple days after, in October, where the predicted tides are in blue, and the observed water levels at the tide gauge station are shown in green. And back in 2015, we recognized that the contribution from winds, persistent easterly winds, were really important. We also had water level contributions from hurricanes passing very far offshore, and we had water level contributions from rainfall. So we've known for a long time, almost 10 years now, probably more, that there are many factors that can contribute atop the highest predicted tides of the year, to flooding in coastal communities. So this is nothing new, but what's been happening over the last 10 years is that we're getting a better understanding of factors other than tides, other than wind, that contribute to coastal water levels, and really the importance of sea level rise. So this schematic is really putting all of these factors together to show how sea level rise on the left can increase the mean water level and the relative contributions from all of these different sources. And something I want to mention here that's shown in the schematic, but I haven't referenced yet, is this the groundwater table. So with as sea levels rise, the ocean exerts a hydrostatic pressure on the fresh groundwater table, and that can push these freshwater lenses up, and that can also contribute to flooding. This can also coincide with the land sinking, which is called subsidence. So we expect, or we predict as scientists, that sea level rise is going to continue to increase the frequency of flooding outside of extreme events. And in the Southeast, we have uncertainty of the rate of sea level rise within our predicted range for different emission scenarios. Here I'm showing from the 1980s through 2050 sea level for the Southeast. This is provided by NOAA for these different scenarios. And the mean projection for the next 30 years is about 11 inches. So what does that mean? We've seen 6 inches of sea level rise at the Beaufort tide gauge over the past 20 years. So what might 11 inches on average, or 10 to 15 as a range, how might that amount of sea level rise look in, let's say, down East Carteret County, the area behind Beaufort, in the next 30 years? So here, this is just a bathtub model showing what areas might be inundated by this amount of sea level rise. But for the areas that are not underwater within these projections, how frequently would flooding occur? What tools can we use as scientists to try to figure that out? Well, we use tide gauges. So here I am showing a tide gauge, which is located over a marine water body. And the water level in this scenario is representative of what we observe with regard to flooding on a coastal roadway. So as water levels come up with the tide, they can come up through stormwater outlets and up out onto roadways through these drainage networks. And we use these tide gauges to provide predictions both at a seasonal level, but also over longer timescales of how many days of high tide flooding we might expect in a year through that mechanism that I just showed, where water can come up through the stormwater networks or just over top low-lying shorelines. So you can go to NOAA's monthly high tide flooding outlook for the Southeast, which is what I'm showing here, and they provide predictions for tide gauges. So you can see that there's 1, 2, 3, 4 tide gauges within North Carolina. And for the month of December, it's unlikely at the Beaufort tide gauge that we'll see flooding from high tides. And we already talked a bit about that from our North Carolina king tides calendar. So looking farther into the future, NOAA also provides from this tide gauge data an estimate of the number of high tide flood days per year for different emission scenarios. So we have our best case scenario on the left and our worst case scenario on the right. And they're showing right now, or they're predicting right now, that we'll have only a handful at the Beaufort tide gauge of high tide flood days per year. But we should see an acceleration under any emission scenario and the number of high tide flood days per year. But tide gauges are not intended to capture all sources of flooding. They're intended to capture marine contributions, but not contributions from rainfall, for example, like I'm showing here. So now we're at maybe a low tide or a mid tide, and there's reduced capacity within the stormwater network. There's nowhere for rainfall to go or rainfall runoff to go. So this is a common mechanism for flooding in our coastal communities. Here I'm showing a GIF from Beaufort of water, just a little bit of rainfall that compounds with reduced capacity in the stormwater network and leads to flooding on the roadway. Okay, tide gauges, they can't capture land-based contributions to floods. They're also really sparse. We only have a handful of them in North Carolina. And like Chris said, we have a lot of coastline. So my question as a scientist is, how often is it actually flooding in coastal communities? What are the impacts of these floods? And what is the true burden then of sea level rise? And how does that vary across the state? So we know that the spatial scale of these floods can just be block by block at a time. They're hyper local. They can be really short-lived, lasting just a couple minutes to several hours, and they can occur from many drivers. So over the past several years with my colleagues, I've been developing and deploying sensors that can measure multiple causes of flooding in coastal communities. And we call these the sunny day flood sensors. So they consist of a water level measurement device that we put within a stormwater network that can communicate water levels within the drain in real time to a gateway that is located on a pole or somewhere high that also has a camera in it. So with this setup, we can get the mechanism for flooding shown here. So water level coming up through stormwater networks and out onto roadways, but also these land-based sources like rainfall. And then the water level sensor is located within the drain. And then over here in Carolina Beach, it looks a little bit different. The stormwater network's a little bit different, but still the same camera and pressure transducer or water level sensor. So we're now within 4 coastal communities in North Carolina. And I'm a big believer in creating devices that anybody can make themselves. So all of the sensors that I'm going to show you today are open source. You can go to our GitHub and you can make them yourself. You can click on the links and buy all of the components. And as long as you can YouTube how to solder, you can make this sensor. So version 1 was designed to be plugged in. It had Wi-Fi capabilities, and we're trying to use it in communities like Beaufort and Carolina Beach that are a little bit more urban. But we now recently came up with version 2, which is solar powered. It's cellular or has cellular capabilities. I think it's pretty slick, and it's still open source. So this is a photo from last week with my PhD student and our undergraduate researcher and our electrical engineer down at North River Bridge in down East Carteret County, and a corresponding pressure sensor that's just to the side of a roadway in sea level. And this is what the image looks like from this camera. So looking down the road, we'll be able to spot flooding as it occurs at the only entrance to down East Carteret County. So all of this data is available in real time to you. There's a link at the end of my presentation, but you can also just go to GoSunny or goncsu.edu/sunny. And this is the geospatial depiction of the data. We also provide time series from the drain and the camera images or the most recent camera image to preserve privacy. So all of this data is currently being pulled into other state agencies' data viewers. So you'll see some of our sensor data coming up in Contrails and also with DCEM. Okay, so that's the background. Now I'm going to convince you, the title of my talk, that it is flooding on land more than we know, more than our sparse tide gauges suggest. So we're going to start in Beaufort and we're going to make our way through Carolina Beach and then to down East Carteret County to sea level. And what I'll show you is that the water level contributions from land-based sources are really significant. And wind is also really important in our region, which is not something new, but we're quantifying it and we're providing evidence to communities of how important it really is. So these are all images from our flood cameras. And we're going from more urban to rural, from left to right. In Beaufort and Carolina Beach, we have stormwater networks. In sea level, we do not. There's more flood data in Beaufort, and in down East Carteret County, there's less flood data. So our first analysis of the data from the drain from our sensors was done by our postdoc Adam Gold, who's now with the EDF. And this was using the Beaufort sensor, which is right next to a tide gauge. And we did this on purpose. We wanted to see side by side what we're missing. So this is a GIF from the flood camera in Beaufort showing water coming up through the drain. And this is on the right is the corresponding time series of water level from the drain. So the road elevation is marked with that dotted red line. Our measured water level is in blue, and the tide gauge measurement is in pink. And they're matching nearly perfectly. So during a flood event like I'm showing here, the tide gauge is doing a really good job. But that's not true when it rains. So when it rains, whether it's at the highest part of the tide or at mid-tide, we can see flash flood events, which is what I'm depicting here with this black line, that are not picked up in the tide gauge records. And again, The tide gauges were not intended for this purpose. So how much are we missing? How many instances of water on the road are we missing when we're making these predictions every year from the tide gauges? Well, in Beaufort, for just a 6-month period, we found that 25% of the flood events were occurring on rainy days. So this is just a cross-section of the road where my camera is over here on the left, and it's looking at the drain over here on the right. And each of these lines are instances of water above the storm drain elevation, and then plotted against this threshold for flooding that we use from our tide gauges, and we being NOAA, and then another flood threshold from the National Weather Service. So you'll see that above the high tide flooding threshold, there's only 4 events that we might expect to see from a tide gauge. So it's missing quite a bit of our flood events. So Beaufort, knowing that rain was a problem, but trying to keep the tide out of the drain, they wanted solutions. And one of the solutions to keep the tides off the road are these backflow prevention devices. So these are just schematics of different devices that you can put on an outfall or within a stormwater network to prevent the tide from coming up through the network and out onto the roadway. And on the lower right, I'm showing an application, or an easy one to see, in Carolina Beach. So this is a duckbill. So once the duckbill is totally submerged, it curls up, and it prevents water from going up through the pipe. But when the water levels are low, at low tide, it opens up and can allow rainfall to escape. So Beaufort ended up installing an inline check valve, which again just blocks water from coming through the pipe back in 2023, spring 2023. And what I'm showing here on the bottom is a time series from that Beaufort gauge for an expected king tide event back in August. So these are our measured water levels, and you'll see before August 31st, they're low, they're below the roadway elevation. And the actual water level at the tide gauge was much higher. So now I'm plotting the NOAA observations. So water levels at the tide gauge are shown in pink. And the backflow prevention device did a really good job at keeping the tide out until the highest water levels, where we still see flooding during the biggest king tide events. So communities across the state are installing backflow prevention devices to try to keep the tide out as best they can. Carolina Beach has been doing this for a long time. In Carolina Beach, the flooding looks a little bit different. There are really low-lying shorelines, and individual parcels or residences have different elevations of bulkheads, in addition to backflow prevention devices at each of these outfall locations. So what I'm showing here now are 2 different mechanisms for flooding in Carolina Beach. So on the GIF on the left, this is due to overland flooding, where water comes down the roadway, and I'll show you a model of this in a second, comes down the roadway and floods a low-lying intersection. So it overtops a shoreline farther down the road and travels down the road. On the right, I'm showing flooding due to rainfall runoff, where water is conveyed down this tiny slope into a low-lying area. And because there's no capacity in the stormwater network, the intersection floods. So in Carolina Beach, over the past year, we measured 45 instances of water on the road. What I'm showing on the left is a plot of flood magnitude, so the depth of water above the road and the duration for these 45 flood events. And you'll see that only 3 of these instances of water on the road were associated with an extreme event. So flooding is happening a lot in Carolina Beach outside of extreme events. This is not new news to anybody that lives in Carolina Beach, but now we have some numbers to associate with the frequency. So this is all work by my PhD student, Thomas Thalen. And in digging into this data, he first wanted to see, are any of these flood events unexpected by the town? So the town has put significant investments into trying to maintain safety for traffic or vehicles through these gates. So this is a gate showing the road is closed during a flood event this past year. And they close this gate whenever their local tide app says that the tide is going to be above 6 feet. So within our data record, we went back and we found that 20% of the floods that we measured occurred when the predicted tide was above this threshold. So the town expected 20% of these floods. They were also on watch, on flood alert, for 50% of the floods. So they have staff that they keep on site to put those gates down whenever the tide app is greater than 5.25 feet for the expected tide. Okay, so that's a lot of floods. They're ready for 50%. But then 30% of the floods were totally unexpected and were below the town's threshold for this flood hazard. And these are the floods that we were really interested in. How could we help the town be more aware of what was leading to these floods? So we have all this data, but they're just single points in time and space. And we wanted to develop a model, a numerical model that could show all of the different contributions to flooding. So we coupled ADCIRC, which is an ocean scale hydrodynamic model developed out of UNC Chapel Hill, with 3DI, a community scale hydrologic flood model. And the domain is shown on the right. And we use this model to try to parse out the different contributions to the floods. So what this GIF is showing is for a flood event that happened this past January, what if the forcing was tides alone? Well, the water would not have reached Canal Drive. So Canal Drive is shown with this white line, and the water level from the yacht basin, the basin behind Carolina Beach, did not extend into the roadway. But when we add wind, we see that there's flooding of Canal Drive. And this is in good agreement with our measurements at our sensor in the drain. So for this case, we're able to decompose the different drivers. And this is important when we're thinking about solutions. So we want to use this model to test the effectiveness of different adaptation strategies. So not just looking at how a flood mitigation approach might work now in 2023, but how it might work in 7 years, in 2030, or in 2050. So how do we, as scientists, figure out what adaptation strategies to test within this model? Historically, what we like to do as scientists is just come up with all of our own ideas and then go to the community and say, why don't you do this? Why don't you raise a bulkhead or elevate a road segment? Or maybe you should add some pumps. But that is not the approach that we should be doing. So communities have preferences and values about how the landscape looks. And it's important that we go community by community and gauge what these value systems are and try to understand them and use their ideas for adaptation within our models. So that way the flood mitigation strategies that we're testing might actually be the ones that are desired by the community. So right now we're conducting surveys within Carolina Beach. I think my students spent 3 hours yesterday peeling stamps on the postcards. So if you're in Carolina Beach, you'll expect to see the postcard on the left, inviting you to take a survey so we can better understand how these floods are impacting you now and have been historically, and your preferences for different flood mitigation strategies. But we're still scientists, and we need to test our model and see if we can even model any of the strategies that might be desired by the community. So what I'm showing right here is some potential strategies. For example, what if we just raised the shoreline everywhere to try to keep water out from the bay? Well, at present day sea levels, that works pretty well. But if we increase the sea level to what we might see in 2050, we actually see that water comes or finds a way. Water always finds a way. And it actually comes from the north and floods down Canal Drive. And what if we add another contribution to flooding that we didn't model previously? What if we add rain? Well, rain has nowhere to go. And higher shorelines actually trap water within the road. So we're just testing the model, but we'll be working within focus groups with the community after our survey is complete to try to model the different scenarios and see which ones work best for the community. So really quickly, I think I have about 10 more minutes. I'm going to scramble through some of the other work that we're doing as part of the Sunny Day Flooding Project outside of my group. And that's specifically related to impacts. So we know that there are impacts from these floods on traffic and business revenues. But what about water quality? There's been one study so far out of Chesapeake Bay that shows that tidal flooding can increase nitrogen loading in recreational waters and can result in fecal indicator bacteria that's higher than REC standards. So in collaboration with Dr. Natalie Nelson and Dr. Angela Harris and Natalie's PhD student, Megan Carr at NC State, we've been looking at how tidal floods are contributing to water quality and potentially if they are health risks. So this is showing a schematic like before where water can come up through stormwater networks, but let's also consider what if there's exfiltrated sewage? What if there is contamination within soil or within these pipes themselves from sewage? Could that escape out onto water, onto roadways, or into adjacent waterways? So within the stormwater catchment basin in Beaufort, if you look in the upper right, there's a lot of trash in these catchment basins. There's also biofilms within the pipes, and there's stagnant water. And this can be breeding ground for different bacteria. There's also, like I showed in that GIF a couple of slides ago, there's also trash in this water, floating trash from just topped over trash bins or pet and wildlife feces. So Natalie's student, Megan, has been sampling water quality in both Beaufort and Carolina Beach for the past year and a half. And I'm only going to show results from Carolina Beach, but she went block by block and sampled surface waters in the roadway and in the neighboring water body for the fecal indicator bacteria Enterococcus. And she did this for 3 events this past summer. And I want to note that floodwaters are not regulated. So the only standards we have are these recreational water quality standards. And so we're going to compare our floodwater samples to these REC standards, which is 100, right here, 100 MPN per 100 milliliters. So what we found was that almost all of our samples during these flood events exceeded the recreational water quality standards. and in some cases by a lot. So upwards of 10,000 mpn per 100 milliliter. So we know that the water quality is poor in the roadway during these events. But we don't know yet what the source of the pollutants are or how they may impact human health at all. But we created this fact sheet that's at the link in the lower left. And I encourage you guys to go take a look. But just exercise caution and tell your friends in coastal communities to not walk through these floods. And if you walk through them, if you're exposed to the floodwaters, wash your hands, and don't let children play in the floodwaters. Okay, so last but not least, I want to talk about Down East Carteret County. So we've started to put out these sensors, and I emphasized that tide gauges are also scarce along our coast, but our sensors are not everywhere, and we can't put them everywhere. So how do we monitor flooding over large spaces like Carteret County? So going back to this map, Carteret County, I don't know if you can see my cursor. It's the Down East area spans these two green dots. So over such large areas, how might we be able to get at the frequency of flooding or understand flooding outside of individual sensors? So for this, I have joined up with the experts in remote sensing in the state out of Tamlin Pavelski's group at UNC Chapel Hill. And we're trying to gauge the usefulness of satellites in capturing flood extent. So satellites that are public and somewhat low resolution and are just optical, like I'm showing here on the left. So this is a planet satellite, and this is the Down East region. So this darker area here on the right is actually flooding on the roadway and then flooding in the marsh. But we also wanted to look at even fancier satellites that are super high resolution. So this is called a synthetic aperture radar satellite. And specifically, we're buying satellite images from this company called Capella. So this is a scan from Carolina Beach, where we started this project, and we're now funded by NASA to expand it to Down East and also to New Bern. So the image on the left is the SAR, the SAR image from the satellite of the marsh, and then on the right is from the Sentinel satellite, which is the publicly available satellite. So you can see that the resolution is very different between the two sensors, and so this high resolution synthetic aperture radar is hypothetically really useful for getting block by block information on flooding. So our first test case was in Carolina Beach. And what I'm showing here are some of the scans. And this is really preliminary work, but I wanted to share it. And what we're finding is, while we can task these satellites in real time to position themselves and take an image, take a scan of Carolina Beach, the angle that they're at can play a huge role in whether or not they can see flooding. So some of these features in the middle plots are due to a bad angle. And it's just really hard to differentiate between the dark blue, which is what we would expect to see as flooding within these block by block features, versus just the blue in the bays. So we're struggling within the urban settings, but within vegetation, it's really clear when we see flooding of vegetation. So here I'm showing different time periods from the satellites of flooding in the marsh in Carolina Beach. So this is a work in progress. And last but not least, we're also trying to get information from cameras using machine learning. Okay, so applying all of this to down east. So we've talked about Beaufort. We then moved to Carolina Beach and now down east. Roadways in down east are flooding more than anywhere else in the state. We've only had a sensor in down east for 7 months. So since this past April. And over those 7 months, there have been 94 instances of water on the road. And the depth of water on the road is really significant, almost 2 feet. So this extends into neighboring properties significantly. And this is a little levity to the end of the presentation. This is my favorite image from one of our cameras. It's a fox in the foreground and then a flood in the background. And we only take images every 6 minutes. So I just thought this was so cool. But in comparison to other places in the state, what we've talked about in Beaufort over the past year, over 12 months, we saw 65 instances of water on the road, and in Carolina Beach, 45 instances. So it is flooding a lot in down east. And the big point here is that the nearby tide gauge, which is in Beaufort, does not predict the majority of these floods. So 66% of the floods are not predicted by the Beaufort tide gauge. So in these regions that are relatively close to a tide gauge, but geographically different, so this is bordering the estuary, there are other drivers that are really important, like wind, rain, and groundwater. So we have a lot of work going on across the state in down east, and this is really the focus of a lot of collaborations between the different universities. So we're collecting information from surveys over many years on flood impacts and risk perceptions. We're trying to understand if people are leaving these areas due to floods from sea level rise. We're also trying to work with NCDOT to figure out how to prioritize different roadway retrofits using different mathematical and numerical techniques. And then we're working with communities through workshops, trying to learn through oral histories, what it means to live with water, both within North Carolina and the Down East region, but also within seemingly different rural settings, but potentially similar in Hawaii. So within these regions, there's limited economic and political resources for adaptation planning. So we're trying to combine some of the models that we're building out of our different groups with data from residents to understand what the vulnerabilities are in these different regions, how they impact communities, and really providing evidence and tools for different adaptation planning. So with that, I think I'm on time, mostly on time. I threw a lot at you within this presentation, but some key takeaways. Land-based measurements are needed to capture floods from sea level rise. Our tide gauges have given us a wealth of information about flooding, but the proxies currently underestimate how much it is flooding in our coastal communities. And that's partially because wind is really important in North Carolina. What we're finding in terms of impacts, water quality can be a concern, and we don't know the sources, but just take care and wash your hands. And lastly, strategies for the future. Sometimes it can be really depressing to look at these statistics, and it's definitely, it's hard. It's hard to live in these communities for so many reasons. This might seem like only bad news, but there's a lot of work going on within communities to come up with strategies, and how we go about doing it will differ from place to place, but the take-home message is that they need to be locally driven strategies and solutions. And we as scientists need to help make sure that these decisions are made with the best possible information. And with that, I'll take any questions.
Dr. Anarde, thank you very much. Wherever people are at, they can give you a great big round of applause, or they can drop clapping hands emojis into the chat for you. That's great too. Thank you so much. Very interesting, exciting work that you've got going on between your research lab and all of your collaborators.
Thank you.
I'm curious to know. Yeah, I'm curious to know what our viewers are thinking. So we do have several minutes available here for a little bit of audience Q&A. So folks, drop your questions there in the chat. I was impressed, Katherine, by the number of collaborators on this research and on these projects. Like universities all across the state, it looked like just about, were all contributing expertise and time and resources and students. And that must, I'm wondering if that makes it a lot easier to do this kind of work, to get buy-in from communities maybe, or if it's just, you know what, it's easier to get NASA to fund something if we have 5 different universities contributing to it.
Oh, that's an interesting perspective. I haven't really thought about it as an en masse approach. I have approached all of these problems through conversation. So Miyuki first went to Beaufort and spoke with Greg there and just asked what was going on. And then we did the same thing in Carolina Beach. And sometimes what's going on isn't the expertise that we have. Actually, a lot of the time it hasn't been. So then I just go to my friends or I look across the state, and we have so much expertise within the state that I think is needed to solve some of these problems related to floods from sea level rise. So it's really it's not a let's get our expertise together. It's what's going on and who do we need to help solve the problem.
Yeah, interesting stuff. I mean, looks like it's working very well.
Yeah,
getting everything together. So let's see. Question for you from the chat. Have municipal officials been accessing this information more to alert residents and guests to flood hazards? If they're basing their information on tide gauges, it seems like they're missing a lot.
So within the town of Carolina Beach, they use the sensor network that we've installed to close the road. So for hazard mitigation. But they haven't used it in a predictive sense because we don't provide predictions. We're just measuring what's happening on land. So still the only information that we really have to help communities prepare are the tide predictions. But looking into the future, I could see tools being created that take wind forecasts, and once we understand the different ingredients that lead to flooding in these communities, we could at least try to extract weather information or predictions and try to give a better sense of when they might need to close the road. But I think models are really needed to look into the future to include all of these different components to flooding. But camera images are really useful for the different communities. It's good to see flooding. Time series are hard.
Right. I guess if they're looking at gauges and charts, then finding, just knowing where the low-lying spots on the roads are just sort of comes down to your roads people and your facilities people and your town managers just sort of knowing the intersections and what might happen versus having that picture that's real time that you've set up.
Yeah, and I guess that statement was a little bit of a simplification. A lot of these communities are fishing communities, and they've lived by tide predictions their entire lives. So everybody knows how to read the tides, and just compare the predicted tide to an elevation. And that is a very useful tool for some of these communities in predicting floods.
Understood. Okay, another one from the chat for you. They write, I would be interested to see what the flood sensors would capture in areas where there is no stormwater infrastructure or areas with planned development zones that might be affected.
Hmm, me too. So down east does not have stormwater networks. There were ditches, and there are some remnants of the ditches that are now infilled with marsh. So in those cases, our sensors are directly on the side of the roadway. And what we're finding, there are some gauges that are operated at a state level as part of like the Feynman network that are along rivers. But if you go one creek over, the water level signal is different on the road. So there's just a lot of variability in these estuarine communities that don't have stormwater infrastructure and flooding. So I'm also interested to see over the next couple of years what our data shows for those communities. And development. There's a lot of development in ghost forests and down east, and that's something that we should be measuring, how often it's flooding in these new areas of development.
The photo that you shared at the end with the fox crossing the street sort of got me thinking, maybe just as like a natural history person, about the ecological wildlife impacts of, yeah, increasing development on North Carolina's coast, along with sea level rise, and what a flooded roadway with high fecal bacteria counts means for the wildlife that are moving through the area, and disease transmission and spread that can happen. All of those things end up intertwined.
Somebody should look at that. I wish I had that expertise, but that's a good question. Angela Harris has been thinking about how some of this bacteria may be incorporated into soils. So when floods reside, does that bacteria then live in the soil, and for how long? And how might that play a role in the ecology or wildlife disease transmission?
Oh wow, that's it's wild to think about all of the connections that get made, all the various impacts that uh I don't know. I don't live on the coast, so I would say that's a puddle, right? But it means so much more in the context of these global climate change patterns that we're seeing, sea level rise, all the way down to block by block, people having to, people trying to live their lives, do what they do every day.
Yeah. And it does sometimes just look like a puddle, which is some of the concern with the water quality, that children are playing in the puddles.
Mm-hmm. Yeah.
And in some of these communities, they're tourist communities, and we don't yet have tools to educate our tourists that this is salty water that comes up through stormwater networks, and it may have bacteria.
All right. Last question for you. Michael wants to know what you think about using drones to supplement your satellite imagery, even though they write the drones might not be as convenient or as real time.
I think drones can give a lot of information on the spatial extent of flooding. So whenever we can, and if it's feasible, some of these floods are at night. Actually, a lot of them this year were at night, and we weren't able to fly a drone. So drones are really good to also compare against satellites. But I think the utility of the satellites, the synthetic aperture radar, is that it can see through the dark. So in that sense, and over very large spaces, if it's cost effective. Right now, it's pretty costly. But drones can definitely supplement some of the satellite information.
Excellent stuff. And so you said the postcards, looking for community input and feedback, are going out soon. Or had they already gone out?
They're going out soon. It takes a while to stamp.
Yeah, absolutely.
It should be
And
by
then
next.
yeah, and then to get people to actually send in the feedback and get the stories and the information and then pull it all together to tell the story. We'll have to have you back on the program in order to see what these communities are saying and thinking about the flooding, because that feels like such an important part of the work.
Oh yeah, definitely. And I'm not a social scientist. I'm an engineer, but somebody like Muki would be amazing. Somebody that's analyzing the human data from a social scientist perspective. Yeah, I recommend Muki.
Sounds good. We're getting all angles on this issue here on the program. Well, Dr. Anarde, thanks for being on the Lunchtime Discovery series. Really appreciate your time.
Yeah, thank you. This is really fun. And thanks to everyone who tuned in.
Thanks, everybody, for being here. We'll be back here again next week for another edition of the program. We're going to be going to the moon next Wednesday at noon, so don't miss out. Dr. Amy Fagan from Western Carolina is going to be with us. It's going to be great. We had a great time today. I bet we're going to have a good time next week as well. So I hope that I'll see you again here at the Lunchtime Discovery Series. Make sure that you check out naturalsciences.org. That's the museum's website. You can see the calendar of events there and get information about the upcoming programs just like this one. You can also head to eenorthcarolina.org. There you can get information from the Office of Environmental Education, including the ability to sign up for the newsletter for this program. That way you get this YouTube link in your inbox every week. All you got to do is check your email, click through, and join us. Get your questions asked on air live and learn interesting things from interesting people. So I hope I'll see you again soon. Thanks for being with us today, everybody. Have a great week. See ya.